Okay, welcome to all. So today we are going to discuss Gram-Schmidt orthogonalization. So this is the list of content, concept of orthogonality, process, an example, then its need in digital communication, application, advantage and use in real world, and conclusion. So what is Gram-Schmidt orthogonalization? What it does? So it is a mathematical process used to convert or derive a set of linearly independent vectors or signal into a set of orthonormal basis function. Means we will have a set of linearly independent signal. Linearly independent means there is no relation among them. Okay, so S1, S2, S3, S5 up to Sm, these are Li signals. Okay, then we will convert these S1, S2 up to Sm into phi1, phi2, phi3 and phi m. So these are the orthonormal basis function. What we are doing, we are converting linearly independent signals S1, S2 up to Sm into orthonormal basis function. Okay, now what is the meaning of orthonormal basis function? So these are the linearly independent signal and we are converting them into orthonormal basis function. And now this image, you can see, this is the condition for orthonormal basis function. So this is for orthonormal basis function. What does it mean? It means the integration of phi I and phi j, means phi I, phi j are different basis, right? Different basis. If I and j is different, means if I and j is different, then different basis. So the multiplication of different basis is 0, means if the multiplication is 0, then so you can say this is the inner product. Better to call it inner product. If inner product is 0, then we will say phi I and phi j are orthogonal. If both are same, means phi I and phi I, if we say phi I into phi I, right, then this value is going to 1, means this is the orthonormal condition. So when phi I and phi I का inner product 1 हो जाए, then this is called normal condition, means we are normalization, we are doing normalization. Okay, and what is the purpose? We are transforming or we are changing Li signals into orthonormal function. For what? It is easier to work in communication. There is no overlap because it convert, the signals are orthogonal and orthonormal. And unit energy means normalized. Normalized means the value is 1. Okay, now what is the meaning of orthogonality? So when we have two vector, you all knows, if two vector are orthogonal, let's say this is vector B, this is vector A. If vector A and B is orthogonal, then their dot product is 0, or you say their inner product is 0, right? So if I ask you, let's say this is S1 signal and S2 signal, so their inner product is going to be S1 S2 dt. If this is 0, then we will call that S1 and S2 are orthogonal. Okay, orthogonal vector have dot product 0. Orthonormal vectors are orthogonal having magnitude 1, means they, if I calculate the S1 and S2, S1 means this is the inner product with same signal, S1 dot S1, then this is going to be 1. Okay, and why it is important? This orthogonality is important in communication to reduce interference between signals, right? So it is used to reduce the interference between signals. Okay, now this is the process, means how we will convert Li signals into orthonormal. Remember, our basic work in Gram-Schmidt organization is converting Li signals into orthonormal basis functions. Okay. So as we all know, we will start with linearly independent signals. These are Li signals. Li means linearly independent signals. Now, the first step, we will consider first basis function, orthonormal basis function. How we will orthonormalize? We will take signal S1. What we are doing? We are taking this signal S1, and we are dividing it by norm, means it's, so this is under root of S1 square. This is the norm value. This is the length of S1. You can say length of S1. Okay, or not length, if you can say magnitude. Better to call it magnitude of S1. So this is magnitude of. So whenever we divide any signal by its magnitude, it becomes orthonormal. Okay, so this is magnitude of S1. Okay, so this is basically magnitude written again. Okay, now, so this is the first, because this is the first basis function. Now we will create the second basis function, which is orthonormal to phi 1. So now we will create phi 2, which is orthonormal to phi 1, means perpendicular to or orthogonal to phi 1. So what is the process? So this is the process. This is the formula to compute the orthogonal signal. Then again, this is the process of orthonormalization, means we are dividing V2 by its magnitude. So this is magnitude. You can see this is magnitude. Okay, so you can see this is phi 1 is the first orthonormal basis function. Now we have calculated phi 2. So this phi 2 is the second orthonormal basis function. This is second orthonormal basis function. Now similarly, this is the formula to calculate third orthogonal signal, which is orthogonal to both. We can see phi 2 was orthogonal to phi 1. Phi 2 was orthogonal to phi 1. Now we will calculate B3, which is orthogonal to B2 and orthogonal to B1 as well. Means you can see S3T is orthogonal to both phi 1 and phi 2. Okay, we are making S3T orthogonal to both phi 1 and phi 2. So this is the formula to do this. As we subtract S3 by inner product S3 phi 1, inner product S3 phi 2, this gives you B3. And again we will do same. What we are doing, we are dividing B3 signal by its magnitude, right? When we do this, it becomes a orthonormal basis function, and we will repeat this process unless all the linearly independent signals are converted into orthonormal basis function. Repeat this until or unless all Li signals are converted into orthonormal basis function. Okay, now it is written for in general, if we have k signals, in general the formula is this. So this is general formula to calculate orthogonal signal. So what is the process? First we will calculate orthogonal, and to normalize it, we divide it by its magnitude, so it becomes orthonormal. जैसे ही हम किसी सिग्नल को उसके मैग्नीट्यूड से डिवाइड करते हैं, it becomes orthonormal. Okay, so you can see phi 1 and phi 2 up to phi m all are being calculated, means all are being converted. Okay, next, what is the need of Gram-Schmidt organization GSO in digital communication? Need of GSO in digital communication. What it does, as you know, that it creates orthonormal basis in signal space, so it is easy to use in modulation technique like QAM and PSK. It also helps to enable mass filter detection for optimal signal recovery. Means whenever we want to recover the signals at receiver, we can use this process of orthogonalization, Okay, why orthonormality? What is the? Because it simplifies the signal analysis and improves error performance. Our basic need in communication, what is the basic need in communication? Communication is reduce error at receiver as much as you can. This is the basic need in communication, right? Now, what is application of GSO in signal space? Signals in communication are represented as vectors in signal space, right? So what happens, we do not write signals as it is. So let's say we have xt is equal to sin t, a signal. So instead of writing, we represent it in a vector s1, right? So you can see what all the signals are represented as vector. So instead of writing sin t or sin omega t, we write it as s1. Let's say we have two signals. First signal s1 is sin 2 pi ft. Second signal is cos 2 pi ft. So what is happening? S1 will represent as vector and S2 will also be represented as vector. Instead of writing this in a expression form, it will be represent as a vector, right? Also, we know that Gram-Schmidt organization helps to construct orthonormal basis for space, right? It also helps to design signal constellation diagram. As we know, let's say we are dealing QPSK. So this is the QPSK system. So let's say this is signal S1, this is S2, this is S3, this is S4. You can see all the signals are orthogonal. You can see S1, S4, and S2 are orthogonal, orthonormal signals, right? They are perpendicular to each other. So this is constellation diagram, by the way. This is constellation diagram. Okay, what are the advantages? As you know that error reduces, right? So whenever error reduces, the signal strength, a signal separation due to the improved signal separation due to orthogonality, right? Noise will also be easy to detect and decode with the help of orthogonal signal. Decoding with the match filter will be efficient because of the orthogonality. Overall, it simplifies the design of communication system for both transmitter and receiver. Simplifies the transmitter and receiver. These are the real world. We can use it in OFDM orthogonal frequency division multiplexing in MIMO, multiple input multiple output system, एरर डिटेक्शन है एरर करेक्शन एट रिसीवर, मीन जैसे रिसीवर पर जब हम किसी सिग्नल को डिटेक्ट करते हैं उसे करेक्ट भी करते हैं तो उसमें हेल्प कर सकते हैं. देयरफॉर ओवरऑल वी कैन से GSO प्लेज अ कोर एंड इम्पॉर्टेंट रोल in the field of modern digital communication systems, right? And this is the conclusion. No need to explain again this conclusion, right? Now we have GSO example. Okay, so this is the GSO example. Okay, so example on Gram-Schmidt orthogonalization. So we have taken two signals, right? So S1 S2 and they are Li. These are linearly independent. This is the basic condition, right? 1 or t is linearly dependent and we are taking over 0 to t, right? So what was the first step? First step was, so we have S1 and S2, right? These are Li and we are converting it into phi1 and phi2 t, right? These are orthonormal basis function. OBF means orthonormal basis function. So जैसे कि जानते हैं फर्स्ट स्टेप क्या था, phi1 को S1 डिवाइड बाई उसका मैग्नीट्यूड, राइट? ये क्या है? मैग्नीट्यूड. जैसे ही हम ऐसे करते थे इसको हम क्या कर देते हैं? ऑर्थो नॉर्मलाइजेशन. दिस इज फर्स्ट ऑर्थो नॉर्मल बेसिस फंक्शन. ठीक है. नाउ how will step 2, we will construct the second orthonormal basis function with the help of this second, because on the first instant we took S1, now we will do x2t instead of S1t. Now the second one will take S2t. So what is the formula to find orthogonal signal? This is the formula. Ut is equal to S2t, and this is the inner product between what is it is inner product between S2 and phi1. Okay, so now we are calculating S2t. We will put value of S2. This is S2 and value of S2 and phi1, and we will calculate. We are getting t minus half. Okay, now we will calculate its magnitude. Now this is the magnitude, which is little lengthy to calculate, and it is coming 1 divided by 2 root 3. Okay, so what we have to do, we have to now normalize this. How we will normalize U2? We will normalize U2 with the help of we will normalize U2 with the help of, so U phi2 will be t minus half divided by 1 divided by 2 root 3. So this term, ये 1 divided by this term will go upper, because ऐसे होता है ना, a divided by b divided by c divided by d, तो क्या होता है ad divided by bc, तो ये ऊपर चला जाएगा. तो क्या बचेगा आपके पास? phi2 बचेगा t minus half into 2 root 3. so ये लिखा हुआ है, this is 2 root 3. Okay, so now finally